Could you guys give me some comments? What do you think the questions on this latest quiz is about? You can type on the chat, right? You can recall what you have done over the weekend, and you can recall what we did last time. What is it? What do you think I have in mind when I, make up those questions and have you work on all of them? Any comments? Trig definitions. Knowing the definitions of all the trig functions. Trig functions, trig definition, the ratio between a reference angle and the standard position. The ratio between reference angle and the standard position. What does that mean? What is the ratio between a reference angle and a standard position? I never heard of that. The ratio between a reference angle and the standard position. How do you do ratio between this reference angle and a standard position? Jack, can you elaborate on that?
That's what we had to find in the quiz. Like we had to find the ratio of the numbers in terms of X, Y, and R.
Okay. But that description is not accurate you have there. But thank you for putting there, okay? There's no such thing, okay? Reference angle, the ratio, you will mean that the ratio of reference angle is an angle. Standard position is a position. These two, you cannot do ratio, okay? But you could more, you see what I introduced to you last week, which is really the core of trigonometry, okay? Because one of the questions I have asked when I was a student, okay, I often recall my experience learning trigonometry, right? At the beginning, it's overwhelming, isn't it? You have learned trigonometry, right? You guys came in pre-calculus. You are expected that you have learned trigonometry. If you didn't, you should go back to take trigonometry. Is that clear to everyone? Okay, you cannot make it through this class, and you cannot make it to calculus class, and you will, even if you barely made it to calculus class, you will not make it to pass it. So just don't waste the time. Don't waste the time, okay? So you have taken trigonometry. So how did you feel about that course? Can you tell me how do you feel about the contents of trigonometry? Anybody? Yes, no, anybody? No comments? You had an amazing time? It takes a lot of practice to understand. Okay, thank you, Cortland. Anybody else? How did you feel about that course? Let me tell you how I felt when I learned it first time. It was overwhelming. It was very difficult, wasn't it? If it's very easy for you, you're certainly smarter than I. Okay. And then when, I learn it, I use it, throughout my college years. And when I teach it, I realize I need to teach. I need to teach this stuff. So I have to understand it, right? Otherwise, I'll be talking to myself. So what is the thing I need to emphasize to my students so that they will not only understand and they can be at ease with it? Okay. So today's, when I talk about trigonometry in this class, I basically just go straight to the part that's most important to every one of you. But that part was often overlooked when we were studying it as a student at the beginning, which is right here. Okay. It was overwhelming. It was difficult. You have definition here. You have all these calculations. You have all these equations to solve. And you have, what else do you have? You have all these special angles to remember, right? And I saw students who had remember all these special angles and draw the chart, and they can draw that unit circle chart and stuff. And when it comes to solve a question that's not a special angle, and they didn't know what to do. Okay, when we ask them specific questions or manipulate some like domain and range and in calculus, and they're lost. Okay. Well, as a students, you and I, we all have similar experience when we learn it the first time. And then we need to figure out what is the core of this course? How could I, master it so that I will always be at ease and something like that, right? Sometimes it may not be possible, right? You need longer time to digest, but I think I have come to some reflect with my reflection on learning and teaching this course. And I think I will give you the core part. And the core part is what? The core of trigonometry is right here. It's ARD. So I give you on the first day. Okay. All the questions you're going to encounter in trigonometry. Okay, I'm doing this introduction in order to get your attention, and also I'm pleading to you to be patient with me to explain this. But in the end, I'm hoping you will understand what I say. Okay, all the questions you're going to have in trigonometry, there are two types. Okay, once you understand ARD, okay, one type of question is that you go from A to find D. The other type is from D to find A. And the R is a bridge. All the trig questions you will ever encounter, okay, aside from, proof identity, those are purely algebraic. Solving equation, and all of these questions you're going to be dealing with is in these words. Okay, one type is A to D, and the other one is D to A. I have not seen much of an exception. I have not seen much of exceptions. Okay, and I teach you. I review with you for your trigonometry. Is to make it simple. Okay, so the quiz I gave you last weekend, okay, has one intention only, is that so you just use definition. Okay, this definition Okay, this ARD is the core of trigonometry. If you can just focus on ARD, everything else will come naturally. So that's what I want to demonstrate. Okay, but of course it's going to take time and you have to be patient with me. Okay, you have to follow me. You have to follow me. And so this is a different, this may be a different way of learning because I didn't know how you learned it before. Okay, everybody may have a different teacher in trigonometry, right? You learn it differently, or you're taught differently. So here, this is how we teach. This is how I teach here. Okay, it takes a lot of practice to understand it. Okay, very good. Thank you for your comments. Okay, so ARD, we talked about ARD last week. Okay, A is just angle measurement. It's a set of rules. By this time, I think everybody understands what's angle measurement, right? All the angle measurement is from the standard position. Did I miss something? Angle measurement. An angle is measured from the standard position. That's what happened there. Okay. An angle is measured. So angle is measured from standard position. If it's a counterclockwise, it's a positive angle. Negative angle is a clockwise. Does everybody know that? Does everybody know that by this time?
Yeah. Okay,
so I send you that link, you play with it. You know, that picture tells you how, that's basically a convention. This is the first item on the stage, right? We have a convention. We have some rules to follow. Secondly, reference angle. The measurement of reference angle is different. It's the positive, okay? Every word counts. Positive. Okay, let me put some underline there. Positive, acute. Okay, positive acute angle between what? Between the terminal of the angle and x-axis. So these three items describe what a reference angle is. Of course, reference angle is measured differently. And the other important thing I ask you to do in the quiz is how to write the notation. How to write the notation. Okay, for example, we have sine theta, cosine theta. In that question, you have alpha, beta, theta, and sigma, right? Alpha, beta, sigma, and theta. You have 4 angles, right? You have 4 different angles. Every one of those angles, you are given the terminal. Did you remember? I give those descriptions of the terminal of those angles. And you can imagine, after you have taken trigonometry, you know that there are many angles corresponds to the same terminal, right? Clockwise, counterclockwise, this way, that way. But, okay, sine as a rule, cosine as a rule, the way you write it, sine is always followed by an angle. Cosine is always followed by angle. Okay? You never ever do this. Never ever write this. Sine equals half. Something like that. What's wrong with it? There's no indication of input. This kind of writing will get you 0 and 0 only. You follow me? If I can, I'll give you a negative number. So you must use a notation correctly. Everybody should have paper, pencil in front of you. Okay, mathematical notations you need to practice, right? Gordon just mentioned it takes a lot of practice to understand it. It takes a lot of practice to write it down properly. Okay, you never ever write something like this. Okay, never. Sign need to be followed by something. And what is that something? Follow the symbol, the rule. Input. You have to tell the reader, sign works on this input. What kind of input for all of these functions are? It's angle. Angle. That's the emphasis. That's the other, important part you need to understand. Sine function, cosine function, tangent function, cotangent function, cosecant and secant, all of these functions, the kind of input they take is angles. And every one of you need to make that transition to radians. Do you follow me? From now on, we use radians. We use radians only. In calculus classes, you're not going to see degrees. You only see radians. All right? Radians. Now, the writing. And the other thing you need to understand, I have a summary in one of the questions on the quiz. All trig functions takes what kind of quantity as input? Angles. What kind of output it produce? Ratios. Different kind of ratios. You have a triangle, which is 3 sides, 3, 4, 5, right? The triangle everybody should be very familiar with. If you have taken trigonometry, no, if you have taken algebra classes, it's that famous triangles, right? 3, 4, 5. That is 3 triangles in different quadrant. What will happen? What happened? Okay, there's so much more can be explored. I don't know if you guys noticed. Okay, a lot of things you learn at different places. Okay, they're scattered all over the places. Now they all come together in this definition. What do I mean by that? Right? What do I mean by that? Look at this triangle. Okay, what you had was this, 3, 4, 5, right? 3, 4, 5, right? 3, 4, 5. Okay, so I'm going to make this a bit more proportional. Okay, suppose this is a triangle, right? Some of us remember that sine. What is the ratio? What's the sine of sine? What's the signs of sine in the 4 quadrant? Some of you can recite it, right? Positive, positive, negative, negative. Why is that? That is seen in the quiz. Okay. So we go by the definition. That the description. So when people ask you to describe the definition of trigonometry, you should mention all 3. Okay. Angle measurement, reference angle, because based on all 3, we have the definition. So that's the reason why I mentioned this is a stage set. This is a stage set. Without these 3, nobody understands your definition, including me. Okay, so you have to tell the reader what you're talking about. Okay, so now theta is in standard position, and the point is any point on the terminal side of theta other than the origin. So you pick this point that's not on the origin. Then the trig function are defined as follows. So that quiz is just asking you guys to work on these ratios. And of course, you work on in all 4 quadrant, right? You work on all 4 quadrant. What have you found? sine, okay, is the y over r, right? The y over r. Yeah? In the first quadrant, everything is positive. Everything is positive. Okay, so let me clear this. I'm going to use the next one. Okay. In the first quadrant, if you look at the points, right? In the first quadrant, x is positive, y is positive. In the second quadrant, x is negative, y is positive. Input out, x, y, the points, right? In the third quadrant, it's negative, negative. In the fourth quadrant is what? Positive, negative. From definition, the sign definition, what's the sign definition?
Y over R.
I'm sorry? It's
Y over R,
right? It's y over r, very good. Okay, sine, try to use the right proper notation. Okay, sine theta, suppose the angle is in the first quadrant, right? Is always y over r. R is always positive. So whenever y is positive, sine is positive. Does that make sense? That's why sine is positive, positive, negative, negative. Do you follow me? You don't have to remember these. This is derived from definition. This is derived from definition. Do you follow me? Because y is positive. Y is positive in the first quadrant, second quadrant, negative in the third and fourth. How about cosine? So you have positive, positive, negative, negative. You don't have to make a special arrangement to memorize it. If you know the definition. Do you follow me? I'm presenting this definition as the core of trigonometry. So this is just the beginning. Well, how about cosine? Cosine is x over r. X over r. X over r. X is positive, negative, negative, positive. Do you follow me? So that's why cosine is positive, negative, negative, positive. Do you follow me? Tangent. Tangent. What is tangent? Tangent is y over x. Y over x. So positive divided by positive is what? Positive. Positive divided by negative is negative. Okay? Negative divided by negative is positive. And negative divided by positive is what? Negative. We're using principle number what? 6. Do you follow me? Mathematical principle number 6. And cotangent, cosecant, secant, they're all similar. So do you see that power of the definition? You see the power of definition, but you must know the definition. Along the way, you do the calculation, right? Along the way, we do the calculation. We realize that R is just assuming different values, right? In your quiz question, the R is 5, right? So you have 3 over 5, 4 over 5, 4 over 3, 3 over 4, and all of that, all of these ratios. Then the question is, what if we make R equals to 1? Will this change the ratio? No, it's not going to change the ratio. The ratio will be the same because you can choose any point on the terminal. Do you follow me? So how about I choose the point right on the unit circle? And that will make the R to be 1, right? That's how unit circle comes about. Because it makes everything a little bit easier. Do you follow me? it just makes our calculations a little easier. So you don't have to do trigonometry on unit circle. You can do trigonometry just by definition. You don't need the unit circle. But for simplicity, those lazy mathematicians, many, many years ago, they said, oh, let me do the unit circle. It seemed to make everything so much easier. So in the attempt to make everything so much easier, we introduce unit circle right here. I believe some of you might even remember this unit circle, 4 point. I'm here to tell you it is not necessary, but if you have remembered it, that's great. But if you have not remembered it, it's not the end of the world. It is not the end of the world, okay? So what I'm going to do is that this unit circle is a little bit, do you guys see all the numbers clearly? You guys see all the numbers clearly? What I'm going to do is I'm going to copy this picture and I send it to everyone. So you have that in your, on your pronto. Let me see if I can send that, okay? It doesn't go. Hold on. Okay. It didn't go. Could you check your pronto? There. You should get the unit circle right in front of you. This is for your convenience, okay? This is for your convenience. And it's for our convenience, okay? Now, how do we use this unit circle? How do we use this unit circle? Because from the definition, there are a few very important facts we need to derive. One of the facts, okay? One of the facts is domain and range. Important facts that we need. Number one, domain and range. Because after all, in basic one, we study domain, range, x-intercept, y-intercept. And the other one is inverse function. Do we need this unit circle? No, we don't. It's for convenience. It's for convenience, okay? So now, without using the unit circle, last time we talked a little bit about it, right? The domain and range for sine, right? Did we? I think we did that. Yep, we did that. Just even visually, did you guys play with that link I sent it to you? Did you guys play with that link I sent it to you? This is the I sent. Well, this software, this website certainly have gone through some, improvement and stuff. So I'm just going to, I encourage you guys to use this website, even though, well, at least the trigonometry part. I did not examine all the part. Okay, they have gone through some transition. Okay, I'll show it to you in a moment. Okay, I'll show you in a moment. Okay, hold on. Share. Yeah. Obviously, did you guys see this site? they put all these as, okay? I send this link to you guys for you guys to play. Of course, this will give you reference angles. This will give you reference angles. So what I want you to play is by definition. You don't need a unit circle. We figure out the domain and range. Okay, we'll figure out the domain and range. Every angle you end up, you should end your terminal in all four quadrants, right? When your terminal is on the x-axis, right? When your terminal is on the x-axis, what happens? What is the sign ratio? What is the sign ratio? When the terminal is overlapping the x-axis, what is the sine ratio? Sine of that angle, okay, I'm going to call that angle A, is what? Is 0, isn't it?
Yes.
Or whatever, right? Whatever ends there. It could be 2 pi, it could be 4 pi, whatever. That angle, what is that ratio? I have chosen an arbitrary point, okay? Suppose this point, you choose, I want you to have your eyes on the definition, okay? You choose arbitrary point on the terminal. This point is xy, okay? This point is xy, okay? And what is r? R equals to root x squared plus root y squared, right? And because this point is on the x-axis and the y value is what? Is 0. Do you follow me? Yes? And what is r? What is r?
0.
R is 0? R is root x squared plus y squared.
Oh.
Now we have a point on the x-axis. Do you guys see those ads on your screen? You do? Okay, I think I'm going to switch the screen. Okay, I don't like it. We don't have to use this one. Okay, I see some comments on the chat. I'm going to stop sharing. I'm going to reintroduce it. Do you guys follow me? Okay, now we're coming back here. Okay, we're coming back here. I'm going to show you how to figure out the domain and range for all trig functions, just by definition, right? You don't have to memorize. You don't need to memorize domain and range. Okay, how to figure out, wait. Okay, how to figure out. We have a standard position. So what I like you guys to do, okay, I'm going to mark the standard position. Make that green. That's standard position. Every angle is measured from the standard position. Okay, suppose I have an angle, and this angle is measured from the standard position and ends at a standard position.
Stupid, bro.
Okay, so this is the angle. Hold on. Okay, so the terminal is overlapping with the standard position. So that angle, what is that angle? That angle is 0, 2 pi, 4 pi, and so on and so forth, right? Yes?
Yeah.
Suppose that angle, whatever it is sine of A. Right? And you choose arbitrary point. We choose arbitrary point. Okay, why do I choose arbitrary point? Because definition says so. Okay, so I choose a point. And this point is what? I don't know what x is, x comma 0, because I know it's on the y-axis. It's x comma 0. Yes? You follow me? Does everybody follow me? I'm using definition and definition only. Okay, so now the ratio. The ratio is y over r. What should the ratio be? Y is 0. And what is r? What is r? R is equals to come on, guys. What is R?
X squared plus y squared and the root of that.
But now here, Y is 0. What is R?
What? It's just X.
Huh?
Isn't it just X?
That's right. R is X. Follow me. But when we get sine ratio, what do we get? Y is 0. Y is already 0. 0 divided by R, which is not 0, is going to be equal to 0, right? So the sine value can be 0, right? Sine value, the ratio can be 0, yes?
Mm-hmm.
Now we keep going. We keep going. Okay? We keep going. So the next one, we measure the points. Did you guys write this down? On this position, on this position. How about in between? In between, okay? Did you write it down? When you try to figure out the domain, the range and domain and range, so the angles can be 0, 2 pi, 4 pi, and so on and so forth, right? Okay. So you wrote this down. And next, I'm measuring this angle. This angle ends here from standard position. Okay, this is the terminal. And I pick arbitrary point on the terminal, which is x comma y. And the r is what? And this time, it's y over r. Okay, it's not 0 anymore, but this is the r. This is the r. And r is the root of x squared plus y squared. The numerator is surely smaller than the denominator, isn't it? Yes? The numerator is surely smaller than the denominator. Yes? You follow me? Right? What can the largest value y be?
One.
1? Why 1?
Or not? No, it'd be 3. My bad. Wait, no, it'd be 1 because of the unit circle. No.
The largest value of y, it can really be anything, right? Because you can choose any points on the terminal. But what is the largest value can this be? Or what is the smallest value can this be? Right? That's what you're thinking. Now,
It just has to be bigger than y, right?
well, the denominator is going to be larger than y in this case, right?
Yeah.
Okay. Here's the inequality I'm going to give you. Okay, very useful inequality. Okay, you guys are heading to calculus classes. You should know how to manipulate these inequalities. Okay, root x squared plus y squared. Okay, knowing x squared is greater than or equal to 0. Didn't we learn that? Okay, so this is going to be larger than or equal to y squared. Okay, because of what? I'm giving you some mathematical tools, algebraic tools. Okay, because this guy is greater than or equal to 0. So this one is always at least root of y squared. What is root of y squared? What is the absolute value of y squared?
Y.
Wrong. Absolute value of y. Didn't we learn that?
Yeah. Plus or minus. Oh,
No, not plus minus.
no. Y is the absolute. Wait, never mind.
Y is absolute value of y?
Yeah.
That's a good
Yeah,
question. I'm sure that question is, you're not alone asking that question. Okay, why is that? Why is that?
Is it because when you insert a positive value, you get a positive value, but when you insert a negative value, you get a positive value? So all like values get out of like
Okay,
absolute value.
if you think of y can be positive, negative, 0, right? Yes. Look at some examples. Look at some examples. If y is positive, say positive 2, and root y squared will be 2 squared, right? And 2 squared is what? The square root of 2 squared is 2. What if y is 0? What happens to root y squared? Is root 0 squared, right? And that's going to be 0, right? So in this case, is it absolute value of y? Is this the absolute value of 0? Last but not least, which is the hardest part to understand, What if y equals to -2? What is root y squared? It's going to be root -2 squared, right? How do we operate that? You will operate the inside of the square root, inside the square root, which is going to be 4. Square root of 4 is 2. And that is equals to the absolute value of -2. Do you follow me? Just a few minutes ago, someone says, okay, someone says, positive negative. Root y squared equals to positive negative y. Could you write that down, what you meant? On the chat. Could you do that, please? Yes? You're writing it down, or you're shy, you're being shy? Common but terrible mistake. This is the all-time common and terrible mistake. Okay, so we were doing trigonometry, but now we encounter something basic. Another common mistake. Okay, it could be x squared, it could be y squared, it could be omega squared, it could be anything. And the other common terrible mistake is this one. I don't know if that's what you meant. Okay, someone just mentioned that, it caught my attention. These are common, terrible, horrible, extremely bad mistake. And I will explain to you why. I will explain to you why. Okay. You ready? We will come back to this, come back to this place. Come back to this place. Okay. If we plug in all possible positive numbers in this place, right? Suppose I put 3 here. This is going to be 3, right? If I put a 5, this is going to be 5. So this is true for all possible numbers, or all positive numbers, yes? So for any positive y, root y squared is equals to the positive y. Positive y is the same as, remember we said that the absolute value of positive number is the same as the number, right? And for y equals 0, and this is also easy. For y equals 0, I want everybody pay attention to this, because in calculus classes, we often see our students losing points on these matters. They lose at least 10 points, sometimes 20. On these matters, okay? So root y squared when y is 0, that's going to be equals to what? It's going to be 0. Of course, 0 is the same as absolute value of 0. Now, for y is for y is negative, what happens?
Becomes a positive.
Of course. But how do you express it? If y itself is negative, it's going to be equals to negative y. And the absolute value of a negative number is its opposite. You follow me? I bet you have questions on here, right? Yes? Yes?
Wait, how would it equal a negative number?
What do you mean negative? Where are you talking about? Here, right?
Yeah.
If y is negative, negative y is going to be a positive. Just because you see negative sign doesn't mean that quantity is negative.
Oh, I get it. So the negatives turn into
That's
the two
right.
negatives are okay.
So it's actually negative of -2 here. Right? You see y is -2. You get the answer +2. That's all right. But -2 is the opposite of the given y, which is negative and negative and -2. Negative and -2 is +2. So you have to put a negative sign in front of it. Otherwise, this is a negative number. This is a negative number. If you do this, you'll be making a mistake. You have to put a negative sign to make the negative positive. Follow me. Just because you see a negative sign, it does not mean that number is negative. The number can be positive. You follow me? So now you understand this, don't you? Yes? We understand that. Everybody, take a close look. Take a close look at this. Yes? Okay. I know some of you may not completely understand, but let's comment on why these are terrible, horrible mistake. Okay, why these are very common. You agree it's that common, right? Because every class I taught in the past years, whether it's intermediate algebra, trigonometry, in pre-calculus, calculus I taught, these are the common mistakes I see all the time. These are the mistakes I've seen all the time. Very common. I can also say they're very popular, but just because they're popular, mathematical truth is not decided by popularity. Okay, so now, what's wrong with this? What does this mean? What does this mean? You have to understand what it means, right? What does this mean? It means for any real number, y, this is true. That is true. You follow me? Mathematical truth, if true, it has to be always true. If false once, it's false. You follow me? So if you have a piece of claim, say sometimes it's right, sometimes it's wrong, in mathematical standard, it will be considered false. You follow me? I know in real life, okay, in some other fields, usually we don't judge truth. We just, look at the statistics. We don't make the truth or false judgment. But in mathematics, we make a truth false judgment. When you make a statement like this, it means, okay, so first we have to understand how your mathematics is understood. This means for any number y, any real number y, it is true. Okay? So now I have a counterexample. I have one counterexample. You guys understand the power of a counterexample, right? False ones, false. Okay, I would say if this were true, then it says, then for y equals to -2, you are telling me when this is a -2, y is -2, and the answer is -2. Do you agree with that?
No.
Do you agree with that?
No.
No.
Good, because we just did it, didn't we? It should equals +2. Do you follow me? A lot of people make this mistake. In fact, this is probably the #1 mistake in calculus entry. At the entrance of a calculus class. Okay, I have a copy of a textbook. I have many copies of calculus textbook in front of me. This one is in one of them. Okay, your calculus textbook. You guys see that? Do you see the calculus textbook? Yes? Do you see that? It has come to 8th edition. The 8th edition calculus textbook. Do you see that? This author of calculus textbook, he has some quizzes. He has he prepares some quizzes for entry level for student who entering calculus. This question is on top of the list. So to him, this is #1 mistake internationally. Of course, it's nationally as well. Because this author's textbook is translated into many, many languages. He's a Canadian mathematician. In fact, he was the richest mathematician in the world. Okay, if you Google his name, Google his name. Okay, Stewart. Okay, if you just Google Stewart, James Stewart. James Stewart. Would you do that for me? Just for the fun of it. Just for the fun of it, right? His name is James Stewart. He's a Canadian. He made his name in writing calculus textbooks. And that also made him fabulously rich. His last residence was in the mountains of, I think somewhere in North America, maybe in Canada or somewhere. Okay. He used his money and built a dream home for himself. You can see that online. Okay, you can Google math textbook author James Stewart and his residence. Okay, all these things will pop up. So you're doing that? Do that. He has died He died some years ago. Such popular author, okay, textbook author. He named this one number one mistake. Do you follow me? I want you guys to remember this. This is number one mistake. So if you make this, guess what's going to happen to you? You're going to get 0. If one of your steps is showing this, you're going to get 0. Do you follow me? I don't just want to tell you this is a mistake. So then you turn around, you're going to make that mistake again. I want you to remember this event when I tell you this is a mistake. And why this is a mistake. There's a counter example. There's a counter example. Because a lot of people, they know that they have heard about this as a mistake, and they're going to keep making that mistake over and over again. I've seen this a lot, okay? And I want to eradicate this mistake from your work completely. So are you convinced that this is a mistake? Yes? Are you convinced this is a mistake? Okay. The next mistake. This mistake. This mistake is even worse. Okay. Teaching for so many years, I often thought of where is the origination of such a mistake? Okay, so I'm going to spend some time to explain this to you because this mistake is so common. There's one year I was on the hiring committee in the math department at El Camino College. Okay, I was on the hiring committee. Okay, so I got a 1 vote to vote who gets to hire, to be hired, who gets not to be hired, right? Okay. One person came to the interview. He had a PhD degree in mathematics. On the interview, we had a question like this. We had a similar question like this. We had a similar question. Okay, this is a question. And this is his answer. Guess what? He's not on the faculty right now. He's not hired. You follow me? He's not hired. He was not hired. Because not only I voted no, I think everybody else voted no as well. This is a very basic mistake. This is a very basic mistake. So if you make such a mistake, you may still be hired by some place you apply to, but you certainly will not be hired by any math department, okay? You follow me? And that guy was not hired by our department because he made such a basic mistake. Now, what does it mean? What does it mean? So when you say something is true, something is false, it really has to go through your head. You can't say, oh, it looks right. No. No. First, you have to understand, what does this mean? This means that for any real number y, okay, the root of y squared is equals to positive of that number or negative of that number. You follow me? So if this were true, what does it mean? You have to see the implication of it. You have to see the implication of it. What is the implication of it? The implication of it, suppose you put 2 there, and you're going to get positive, negative 2. How many do you think this is true? How many think this is true? Of course not. Okay, therefore, this is a counter example. You guys follow me? It's not very difficult to do these things for yourself. But these mistakes are so common. So common. Now, another perspective. The function perspective. The function perspective. We know the root function is a rule, isn't it? It is a rule. The input is going to be this number, right? We just studied basic one, didn't we? We just studied basic one, and root function is one of it, right? If it is a function, it should have exactly one output. Do you follow me? And now you're telling me you have two outputs. And that demonstrates that that kind of definition is flawed. There's no such definition in mathematics, period. Because definition in mathematics, for every input, there's exactly one output. So this output must be what? For that input two, for input two, the output should be what? The output must be unique. So this is the function perspective. Does everybody follow you? Does everybody follow me? Okay. Another thing I like to mention is, because I just mentioned to you, I was thinking a lot about how our students get to this place. Okay, I'm thinking about how our students get to this place. Okay, so my reflections on this mistake. Okay, I think the source of this mistake comes from the following steps. You might have learned. Okay, you tell me if that's true or not, okay? Because I really want to eradicate some of these mistakes. These mistakes will cost you points. Do you guys realize that? These mistakes will cost you points. It costs you a lot of points. A little bit here, a little bit there, you know, all over the places. And by the time you add them up at 20 points, gone. Do you want to lose 20 points because of this? Anybody say yes? You can privately message me. You don't mind to lose 20 points, no problem. You don't care. Is anyone in that situation? Is there anyone in that situation? I hope not, right? I hope not. Okay, all right. I think this kind of problem comes from here. You're solving an equation, and then the answer you get is x equals 2 plus minus 2. That may make our student think, oh, I just take square root on both sides. So square root of x squared is x, and square root of 4 is plus minus 2. How is my guess? Do you follow me? Does everybody follow me? do these steps give you the impression that root 4 is equals to plus minus 2? Then as a result, root y squared give you what equals to plus minus y. You guys follow me? Is there anything wrong with these steps? Is there anything wrong with these steps? From this step, get to that step. In fact, you have learned this from any teacher before. These steps are completely right. Completely correct. But it doesn't mean root 4 is plus 2 minus 2. There are some steps in between it's been missing. Okay, skipped. Whoever this teacher did, he skipped some steps. And this is very common of skipping steps. But it turned out to be fatal. It turned out to be fatal. Okay, so this is my explanation to you guys. Remember, we talked about there are two kinds of statements in mathematics. One is a statement, one is if statement. You follow me? One is a statement, one is if statement. This is if statement. This is an if statement. Okay, so here, this is an if statement. This is an if statement. What does it mean? It says, if x squared is the same as 4, is the same as 4. What are all the possible x values? Okay, so this statement, first of all, it's an if statement. This if statement basically tell you if x squared is the same as 4, which is x squared is 4, what are all the possible values x can be? Do you follow me? Do you follow me? And what is root 4? Right? Root 4 is defined as the positive root of 4. Square root of 4. Okay, any questions, please? What I'm trying to clarify here, okay, of course, you can see it has a long history, right? Years and years and years. I believe that these mistakes will be there forever. Okay. So now, this is just a statement. This is an if statement. Do you follow me? That's from the grammar's perspective. Does everybody follow me? This is an if statement, and that is a statement. They are different structure of sentences. Okay. And next, it basically says if A the same as B, then if both A and B are positive or 0, you can take square root on both sides. And that's what we do. So the next step, okay, is we take square root on both sides. We take square root on both sides, because if this is true, then we take square root on both sides, they're still true. And then, okay, here, let me, provided A is greater than or equal to 0, I just don't want to leave any holes here, okay? Now, because the square root of x squared is absolute value of x. Sorry. And the square root of 4 is 2. So the statement says, well, if this is true, then this is true. If this is true, then this is true. You follow me? Then if this is true, what could x be? You're telling the reader, okay, x can be positive 2 or negative 2. This is the context. And sometimes this is being shortened as x equals to plus minus 2. Okay, so if you look at the shorter version of it, what does that mean? It says, if this is true, then x equals to positive 2 will make it true, x equals to negative 2 also make it true. But it in no way implies, okay, x could be 2 or negative 2. That's what this paragraph says. It in no way implies that the square root of x squared is equals to x, nor the square root of 4 equals to plus or minus 2. It is simply a sequence of if statement. Do you follow me? Does everybody follow me? Are you bored a little bit? Is some of you kind of bored about it?
No, I'm still confused on it.
You're still confused about it?
Yeah.
What is it?
I don't know. I'm just so used to seeing what's it called if you see like x square rooted and then you get a plus or minus. And, no, it's just taking a while for me to get used to it.
Okay, because this is an if statement, you know absolute value, right?
Yeah.
This is say if the absolute value of a number is 2, what can that number be?
Only 2 and negative 2.
2 or negative 2, not and. Okay. So what this says, you see, we need to understand if the absolute value of an unknown number is 2. What could this number be? Right?
Uh-huh.
That's what the sentence says. If the absolute value of an unknown number is 2, what can that number be? Then your answer could be that, or it could be 2,
Also,
or it could be -2. Do you follow me?
yeah. So it's only if you don't know the answer? Is that what it is?
What do you mean you don't know the answer?
And it says unknown number.
The unknown number I imply x.
Uh,
The unknown number is x. The absolute value of x. The unknown number refer to the x. Do you follow me? So you don't know what x is, but x could be 2, because 2 will make it true. -2 will also make it true, right? You follow me? So you really need to look at the structure of sentences. It really is saying, well, it's an if statement. This is called an equation. Equation is if statement. I try to make you guys understand the structure of sentences are different. So you're thinking within that framework. You're thinking within that framework. Do you understand it now?
yeah.
Good. Now, let's look at root 2, root 4, right? Root 4, root 9, root 5, whatever, right? So when this symbol is introduced, okay, this symbol was introduced all those many years ago. In order to resolve this issue, I went back to a lot of textbooks, right? Because I know definition is a king. Right? Anything I do, I cannot violate definition. If I violate definition in my teaching, I'm doomed. I need to come back and apologize to you right away. Okay, there's no point resisting it. Okay, definition is the king. The first time I found the definition about square root appears in a pre-calculus textbook. In a pre-calculus textbook. Even though this definition show up in a pre-calculus textbook, right? So I'm going to, I don't have a pre-calculus textbook to show you, but I have the calculus textbook to show you, okay? So give me a second to see if I can find it. If I can find it, the calculus textbook actually make a little point about it, because knowing this is a common mistake. This is a common mistake. Okay. If I find it, I will take a picture and send it to you. Let me see where is the root function. Okay. You guys can look up whatever literatures you have. Root function, square root. It should be somewhere here. It used to be here, but the new version, they took them away. The new version take it away. I'm not going to spend more time to find this, but I'm going to give you the rationale, okay? And then once I find it, I'll send you a picture. But it's pretty much what I'm saying, okay? So here's the rationale. Here's the rationale. We all understand the idea of square roots, don't we? Square roots of 4 is what? What are the square roots of 4? What are square roots of 4?
2.
2?
-2.
Or -2. Very good. But what's the definition of square root? Okay, definition of square root. Okay, you should be able to find this any literature and it should be consistent. Okay, if a squared equals to b. Okay, then a is called a square root of b. Okay, that's a definition of square root. Okay, according to this definition, the square root of 4 is what? It's 2 or negative 2 because 2 squared, okay? So because, right? 2 squared is 4. 2 squared is 4. Negative 2 squared is also 4, right? You guys agree with me, right? So what
Yeah.
have we discovered here? For a positive number, its square root show up in pairs. Follow me? So what will be the square root of 9? Tell me. What the square root of 9? Tell me.
Positive 3 and negative 3.
Positive 3, negative 3. That's easy, right? Because 3 squared, negative 3 squared, right? And what is the square root of 5? I'm going to leave a question here. I'm going to leave a question mark there. So something squared. So even though I don't need your calculator, okay? We don't need your calculator. Don't grab the calculator. The calculator only give you an approximated value, okay? That's not what I want. I want a precise value. I want a precise value. So what are the square roots of 5? Well, I don't know what the square root of 5 is yet, but I know it will come in a pair. One is a positive, one is its opposite. You follow me? You follow me? Now, if you keep this process going, okay, and of course, square root of 0 is easy, right? 0. And what is square root of 25?
5 and negative 5.
5, negative 5, and you can do that. We can do that forever, can't we? Yes?
Yeah.
Do you think it become fun or it become boring? Okay, Kyle has a question. I'll come back to your question just in a minute, okay? Now, the square root of 25 is 5 or negative 5. Sometimes we know the square root easily, we know the roots easily, sometimes we don't. But we know that the square root of any positive number, okay, I'm making a statement. The square roots of any positive number come in pairs. Okay? Come in a pair. Do you agree with me? And that pair is like one is a positive and the other one is the opposite of it. So if I find one, I find the other, don't I? Do you follow me? Do you follow me?
Yes.
Do you agree with that statement?
Yeah.
The square root of any positive number come in a pair. The square root of 4 comes in a pair, 2 or -2. The square root of 9 is 3, -3. The square root of 25 is 5, -5. I can keep this list going, but my summary is here. Okay. What kind of pair is it? What kind of pair is it? Can you describe it? A pair of what? Opposite. Opposite numbers, right? 3, -3 is opposite. 5, -5 is opposite. If you find one, you find the other, don't you? Do you follow me?
Yeah.
So is it necessary to introduce notation for both numbers? It would not be necessary, isn't it? Because if you find one, you find the other, you just put a negative sign in front of it, isn't it? So that's why the square root of 4, this 2 will be given as root 4. So root 4 is defined to be equals to 2 only. Do you follow me? And the -2 would just be negative of root 4. Do you see that? Do you see that? For +3, we're going to use this notation. When we introduce this notation, this little notation is an operation, okay, to the root operation, square root operation. It comes out as a function, has a unique output. Okay, so whatever the input, the output is going to be unique. The output will be unique. And that output, we want it to be what? This input must be greater than or equal to 0. And the output must be greater than equal to 0. And that is the rule. Do you follow me? You follow me? And now 5 will be the square root of 25 using this notation. I know it's a little confusing, right? Because in the popular software, whenever this square root is mentioned, people tend to think of this, there is equivalent to the notation. Actually, it's not exactly the same as a notation. The notation is intended for the positive or the non-negative root of the roots. You follow me? So let me put it this way, okay? Let me put in the words and you write down the words and you try to understand it, okay? I want you guys to understand it, because if you don't understand it, you're gonna make the same mistake again and again. These mistakes are small mistakes, but as a teacher, we see them a lot. So you're gonna miss 2 points there, here, there, and add up to be a lot, okay? So this function setup, okay, so I'm gonna write it down as this is intended, okay, it was defined to be the non-negative root of the square roots of omega. Okay, so please write it down word for word to make sure you understand. So whenever you use this notation, okay, it is intended, it is defined to be the non-negative. Why do I say non-negative? Because I want to include the zero. The square root of 0 is 0. The square root of a positive number is the positive root of the square roots, because we know every positive number has 2 roots, and these 2 roots are opposite to each other. You follow me? And if you find one, you find the other. So you don't need to you don't need to use a notation. And besides, that will conflict with our definition of function. So now we come back to the square root of 5. What is square root of 5? It's just square root of 5. We know it has 2 roots, and the other one would be negative of root 5. They still show up in pairs. So square root of 5 Do you follow me? And then I'll come to get Kyle's question. Oh my God, time is up. All right, so we will continue trigonometry tomorrow. Okay, but this is a big topics. This is big topics, even though we get a bit sidetracked, but I think it's worth it. Okay, we're addressing some of those very fundamental issues. Let's look at Kyle's question. Kyle says, so absolute value has 2 if statement with 2 unique inputs.
Brother.
What happened, Chris?
Oh,
No. This, I first of all, I don't think I understand your question. Okay, I don't think I understand your question. No. Absolute value doesn't have 2 statements. Absolute value doesn't have a 2 statement. You guys are welcome to stay. I'm going to explain this to you. Okay. I'm going to give you another interpretation. Okay, so hopefully this will help you understand better. Okay. What does this mean? What does this mean? If the absolute value of x is 2, okay, understanding, suppose f of x equals to absolute value of x. And what is if? What does this mean? Okay. It's a very good question, Kyle. Are you still there?
Yep.
Okay. From the function perspective, we know the picture of this one, right? We know that function involves only 2 things, either input or output. Yes? You follow me? Function follow either input or output. Okay. Just be patient with me, okay? I want to give you a thorough explanation. So that's the statement. The function is absolute value of x. It illustrates a tool. It illustrates a statement. Okay, this statement basically tells you how this rule works. How this rule works. And now, over here. Okay, so go from the function perspective. X is given to this function as a rule right here. And gives output. What does this mean? This means if the output this means if the output is 2, what are all possible inputs? That's what it means. You follow me? It's not 2 if statements. Do you follow me? What does that mean? Basically, you know that, okay, so that means you know the output. This is the output, right? Output is 2. The output is 2. What input will produce the output 2? You follow me?
Uh-huh.
What input will produce output 2?
Any real number?
What?
Any real number?
Any real number
that
will produce output 2?
No, that's for the function of x equals 2. No, it'd be like 2. It'd be 2 or -2, right?
It will be either -2 or +2. You follow me?
Mm-hmm.
So it's not a 2, they're not 2 if statement. The if statement is often says you're given certain quantity for input or output. But in this case, it says, well, I want the output to be 2. Can you give me the input? Can you give me all the input that produce 2 as output? Does that make sense? That's what it means. You follow me? By the same token, since we're here, okay, how about x squared equals to 4? Can x squared equals to 4 interpreted using the same way? Absolutely. Absolutely. Okay. If we see this as a perspective of f of x equals to x squared, right? And this is a curve, we know that, right? We know this curve. Okay. Let me just move over a little bit. Okay. And if x squared equals to 4 imply what? The function perspective says, the input is x. My function is here. And the output, okay? If x squared equals to 4 is saying, if the output is 4, we want the output of 4. If the output is 4, what are all the possible input? Do you follow me? So you know the output. Okay, you know the output. Okay, so let me just make some adjustment for. Okay, so what are the input will produce the output for? So the if statement basically says, if this is the function and I want the output to be 4, what are all possible input that produce output for? And of course, that's -2, 2 as well. For that reason, these work you have seen before, there's nothing wrong with it. It's just a few steps being skipped. And these steps basically transform this question to an absolute value equation. So this is the if statement involve squares, and this is if statement involve absolute value. It's a little transition. You follow me?
Yeah. Miss Wang, the reason why I said if the absolute value has two if statements is because isn't the definition of absolute value if we have a positive x, then x is greater than or equal to 0. But if we're given a negative x, then it's negative x. Yeah, it's negative x comma x is less than 0. So wouldn't those two like?
Well, you mentioned x in two situations.
Because I remember
Okay.
writing this in class.
You should go back to watch that lecture. Okay, so could you please go back to watch that lecture again? And if you have questions, get back to me. That's not what I said.
I'll take a
Instead-
picture and put on pronto. I found the notes.
Okay, the absolute value of a positive number is the same as the number. The absolute value of 0 is the same as 0. The absolute value of a negative number is its opposite. So when you mention x, x itself can be positive or negative or 0. Just because you say negative x doesn't mean negative x is going to be negative. Negative x could be positive because if x itself is negative, negative x would be positive. Do you understand?
Yes.
Okay, so please go back to that lecture to watch it again. And do come back, okay? So Kyle share a picture with me. Kyle, well, we really have overdone the test. Could you come to my office hours instead?
Okay.
Okay. And Bailey, do you have any questions? We have some people here. I'm sorry we ran over. Saleh, is it Saleh Azam? Who is Saleh Azam? Are you here? Let me turn on the recording.